All right, we're back. We're on page 3, maybe. Yeah, 3 of notes 11 of Calc C. We're talking about integrating powers of trig functions. This whole page is one problem, and it's the integral of secant cubed. And I'm of the opinion, and maybe the world might actually agree, this is the hardest easy integral or the easiest hard integral in the world. Like it's the dividing line, I think. So let's see if we can do it. It's basically the techniques we've been using. Um, the thing is, it's not the techniques we've been using at all. It's actually integration by parts. So I have another video about this that's almost definitely going to be better than this one. So if you want to watch that instead, like go for it. But I'm going to try to do it. So let's see if I can. So the integral of secant cubed, first thing I'm going to do is I'm going to break it up, factor it, I guess, into secant squared dx. Okay. And this sets us up for one of two things. So the thing that I think most people do, and it's probably partially my fault because of the way the notes are structured, replace secant squared with 1 plus tan squared. Like it feels like the right thing to do. If you try to do it that way, you end up with like 0 equals 0, I think, at some point or at the end, which means you didn't make a mistake, but you didn't go anywhere. Anytime that happens to you on an integration on a problem, it means you basically didn't mess up. You just like went in circles. Which is like good and bad. I mean, you didn't mess up, but also it was a non-productive thing to do. So here what we're going to do is I'm going to say u is equal to secant because, yeah, well, because I don't want to integrate secant, I guess. And then dv is going to be secant squared dx. You can actually do this either way, I think, provided, oh, well, I don't know. Let's do this and see how long it takes. Secant tan dx, and then v is just tangent of x. Okay, so at this point we have let's call this I, the original integral. So I is uv, so secant tan, and then minus the integral of v du, so secant and then tan squared. Secant tan squared dx. Okay, that seems good. I see secant and tan squared. So like, here was our issue. Here we had secant and secant squared, right? And it was like, oh, maybe do a substitution, but that's not going to work. Here I have secant and tan squared. I am going to do the substitution. I'm going to change tan squareds into secants, which doesn't really feel like it's going to work, but I think it's going to work. So here we have I is secant tan. One of the you have a big advantage on this problem if you know how to do this problem, which always reminds me a little of polar, right? When you're dealing with polar coordinates, it's like if you already know what the graph looks like, it's way easier to find the graph. Here, if you know what you're doing, it's easier to do it. It's 1 dx. So I'm going to have to integrate secant anyway, but that's all right. Secant tan. And then minus, so it's minus the integral of secant cubed, but that's just I again. Secant cubed. And then, so I guess I'll do, I don't know what to do. I'm going to keep it all in one integral for now. Okay. All right, that's fine. Sure. So this is I. I'm going to write this 200 billion times. I should just be copying and pasting. Although I understand it's annoying when the person who's making the video just copies and pastes because you can't really do it. Unless you've joined the revolution, which I think you should if you have the means. Just do all your work on an iPad from now on. You can export it as a PDF and like you'll always have your, I can't even imagine, like you'll always have your work because you will never like throw away a piece of paper or whatever. So to integrate secant, you do the weird thing where, so you multiply by secant. What am I doing? You're going to multiply by, I'm reformatting, whatever that means. I'm changing the location of that. Multiply by secant plus tan. Secant plus tan. over secant plus tan. Or you could have it memorized, but like usually when I set this challenge for my students, I want them to like run through it rather than just be like, oh, I memorize it. Because like you can easily memorize the antiderivative of secant cubed, which when we get it, I'll tell you how. Maybe you already know, but maybe not. Secant squared. I think what always bothers me about this method, well, I mean, it's fine, but like the du is in the opposite order, like of what it's stacked on top of. Right, this is a standard procedure. Hopefully you've seen it before, where you like multiply by a clever form of 1, and then you make u equal, so this is going to be u. Then the derivative of secant is secant tan. So let's do two different colors. The derivative of secant is secant tan, and then the derivative of tangent is secant squared. So this is, ow, God, just hit the mic. This is perfect. It's 2i secant tan, and then this will be the natural log of the absolute value of secant plus tan. So there you go. This is essentially done. So plus c. The final thing we need to do is divide by 2. So divide by 2, you get I, but I is just the integral of secant cubed. And then you get secant. Oh, I'm really gonna write this again. I mean, I'm already in, so doing it, but still. Secant plus tan. And then all divided by 2 plus c. All right, so the way that I have this memorized, and it hinges upon memorizing other things, but this is actually, it's the average of the derivative of secant, right? The derivative of secant is secant tan, and the integral of secant, which is the natural log of the absolute value of secant plus tan. So if you have those memorized, you actually have memorized the integral of secant cubed. But like the process is what's really important. So I'm going to show you the wrong way to do it. I don't know, like I don't advise you to do things the wrong way typically, but say you go down the wrong way. This is the wrong path. So you have secant, secant cubed equals the integral of secant times secant squared. Okay, so we're going to replace secant squared with 1 plus tan squared dx, right? And so this is going to be secant plus secant tan squared x. And then you're like, oh, I got tan squared. So if you have tan squared, you can replace that with secant squared minus 1. So you get secant plus secant squared minus 1. And you can see like we're definitely just going in circles, because here we end up with the integral of secant cubed. And that's the integral of secant cubed. So like, yeah, you just go in circles. Now here, I don't know, like there's nothing, I don't think it's salvageable at this point. Because like you can make like u equal tangent, but the derivative of tangent is secant squared, and you don't have enough secants. You can make u equal secant, but the derivative of secant is secant tan. You don't have enough secants for that. So I think it's unsalvageable once you go down this path. Anyway, definitely worth memorizing. Such an interesting integral, in fact, that I'm just going to take a second and show you this. It has its own Wikipedia page, which is like bizarre-ish, but it's an important integral. Like, look at that. Integral of secant cubed has its own Wikipedia page. So I would say it's like, it comes up a lot. Like in Calc 3, you need to know it frequently, and like you just do not want to be deriving it. So yeah, make sure you are aware. I'm gonna share the notes one more time and then end this video and be back in the next video and do some more stuff. probably, I think at some point we just start doing like every integral on Earth. Yeah, pages. This will either, oh my God. All right, so that's either gonna go fast or really slow. Maybe fast, I don't know, because you can always like pause it, rewind it, watch it again, or just skip to where I get the answers, or just type them into your calculator, whatever. Anyway, I'll be back in the next one, and I'm gonna start doing some problems, so I'll see you there.